Math Blast 27. Fraction addition and subtraction word problems. Roadsters Paving Company used 4 2/3 tons of cement to pave Dan's street and 2 3/8 tons of cement to pave Joe's street. How much cement did they use in all? For this problem, I'm going to add the cement that was used to pave Dan's street to the cement that was used to pave Joe's street. So I have 4 2/3 plus 2 3/8. And our units here are tons. So here, I know I have 4 whole, and I'm going to model 2/3 of another whole. So I'm going to draw my lines to make thirds, and I'm going to shade 2 of those 3 equal parts in the whole. Plus I have 2 holes here, and again, I'm going to draw a hole. So this is another hole, and I have 3/8 of that hole. So this time I'm going to draw some horizontal lines on here to break this into eighths, making sure that we have 8 equal parts in the hole. 1, 2, 3, 4, 5, 6, 7, 8. We're going to shade 3 of those. Now, to come up with a common unit, because right now I am working with unlike units, thirds and eighths. To come up with a common unit, I'm going to transpose the lines onto the 2 models. I will draw my horizontal lines making eighths onto this model. And I will draw my lines here, the vertical lines, making thirds onto this model. And now we can see that 2/3 is the same thing as 16 24ths. So I have 4 whole and 16 24ths of another whole. Plus I have 2 whole and I have 9 24ths of another whole. Now when I add those together, I get 6 wholes and 25 24ths. I can pull 24 24ths out to make another whole, which is 7 wholes, and I would have 1 24th left. So it would take 7 1 24th tons of cement to cover both streets. Real-world coordinate grid. Label the x and y axis. Here is my x-axis. Here is my y-axis. To get from Johnny's house to the library, we have to travel 3 units left and 1 unit down. They want us to plot and label a point to show where Johnny's house is on the map. Well, we don't have Johnny's house, but we do have the library. So working in reverse, to get from the library to Johnny's house, we will reverse our travel units here. Instead of 3 units to the left, we would go 3 units to the right. Instead of 1 unit down, we will go 1 unit up. Now, this would be Johnny's house. And we can go back and double check going from Johnny's house this time to the library. We travel 3 units left, 1, 2, 3, and 1 unit down. There it works. So here we want to give the ordered pair for each location. Johnny's house is 7, 4. The school is at coordinate pair 2, 6. Notice how I'm traveling across the x-axis and then up the y-axis. The library is 4, 3. Patterns for powers of 10. Find the value of n in each number sentence. Show how you know. Here, I'm going to draw a place value chart. Let's go tenths to the right of my decimal point, and to the left of the decimal, I know I have ones, tens, hundreds, and thousands. So I'm going to place my number here, 5 2/10, on the place value chart. And it says we're going to multiply by 10 to the n power to get 5,200. So I'm now going to place my 5,200, 5,000s, 200s, 0 10s, and 0 1s. And what I'm looking for is how many shifts were made to the left to get my 2 from the 10th place to the 100th place. 1, 2, 3 shifts to the left, and each shift to the left is a multiplication by 10. So notice the 5 did the same thing. 1, 2, 3 shifts to the left. So all of my digits shifted to the left 3 times, again meaning multiplying by 10, and by 10 again. So this n is equal to 3, 10 to the third power. For B, I'm going to use my same place value chart here. In this case, we're going to add on some place value labels. So to the right of the tenths, I know I have the hundredths. I have the thousandths. And the 10,000ths. Notice this should be thousandths. There we go. All right, so now I'm going to place on my place value chart here my number 155 and 46 hundredths. Now I'm dividing by 10 to the third power. So anytime we're dividing by 10, our digits are going to shift to the right one place value. So each digit would shift to the right one time. And then I'm going to have to shift to the right yet another time. And that would only be 2 shifts to the right. So I'm going to need even yet another place value, my 100,000ths place. So my 6 can shift to that place. Now, my 6 would be there. My 4, 1, 2, 3 would be in the 10,000ths place. My 5 is going to shift 3 places. My 5 from the tens will shift 3 places. And my 1 that was in the hundredths will shift 3 places from the hundreds now to the tenths. So my new number is 15,546 hundred-thousandths. So n is equal to that, 15,546 hundred-thousandths. Whole number exponents, standard form, repeated factors, and exponential notation. Given 1,000, I want to write that in repeated factors. 10 times 10 is 100 times 10 again is 1,000. So that's 10 to the third power, a base of 10 3 times. 10 to the second power would be a base of 10 2 times. In standard form, that's 100. 10 times 10 is 100. Repeated factors, 10, 1, 2, 3, 4, 5, 6 times is a base of 10 with an exponent to the 6th power. That would be 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, times 10 is 100,000, times 10 is 1,000,000. Dividing fractions. Here I have 8 1/4 divided by 1/2. I'm going to show that 4/4 is 1 whole. Here's 1 whole. And if I break that into fourths, it is 4/4. Now, if I am to take that 8 times, 8 times here, that was my 1 whole. Here's the second, third, fourth, fifth, sixth, seventh, eighth. I have 8 holes, and then I want 1/4 of another hole. I'm going to break all of these into fourths. So notice from my 8 holes, if I shade all of these, I have 32 fourths. So we said 4 fourths is 1 hole. 32 fourths is 8 holes. And then we have 1 more hole here, and we have 1 of those fourths. So 33 fourths, let's say 32 fourths plus 1 more fourth is how I show 33 fourths here. Now I need to divide by 1/2. So I'm going to take each of these holes and divide in half. Here's 1, and I can show that by a little bracket here. Here's half, half, half. So notice when I take my 8 holes and divide in half, I end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 groups there. And notice the new hole here, the new hole for why there's 16 groups is half of the original hole. So if I consider this my new hole, what I'm left with here is 1 out of the 2 pieces, or 16 and 1/2 total. Now, so in other words, 8 and 1/4 divided by 1/2 is 16 and 1/2. Now, for B, I have 2 and 1/5 divided by 3. I'm actually going to grab another sheet of paper here so that we can model this one. It looks like we're a little bit out of room. I don't want to cram this in because it's quite the model. So this time I'm going to have 2 and 1/5 divided by 3. I'm going to show this. Let me just show 2 and 1/5 divided by 3 is the problem that we have in the dividing fractions box here. So what I want to do is I'm going to model 1 hole. This is 1 hole. And if I break that into fifths, then I know that 1 hole is the same as 5/5. I have all 5/5 if I have the hole. Now, 5/5 is the same, since I'm going to be dividing that into 3, dividing it by 3 there. Let's show what it is the same thing as here. When we take each of those pieces, each of these fifths that we have, and we break those up into 3 pieces. Now my 5/5 has changed into 15ths. They're still equivalent because I still have the whole thing. But notice that my 5/5 has become 15 15ths. I'm going to write this in unit form here. So 5/5 is equal or the same thing as 15/15. And now we want to divide that by 3. So, excuse me, when I take this and I divide this by 3, then I'm going to take one piece out of each of the 3. And what that then shows is that I have 5/15. I have 1/5 plus 1/5, 1/15 plus 1/15 plus 1/15 plus 1/15 plus 1/15 for a total of 5/15. So dividing by 3, 15/15 dividing by 3 there is equal to 5/15. And I'm going to write that as an equation. Oops. We're dividing by 3 equals 5/15. Now keep in mind that was only one whole. We need that 2 times because we had 2 wholes. So we have 5/15 plus another 5/15. And then I'm going to model my 5th. I need to take this 5th and divide it by 3 as well. So again, this stuff all duplicated for one whole plus another whole. Now I have a whole, and I'm going to show how 1/5 looks. Here's 1/5. I'll write that in unit form here, 1/5. Now, I can show how I break those fifths up again into 15ths, because I'm going to split each of my pieces into 3 pieces there. So here's my 5ths. And I'm going to break each of those once again into 3 pieces. But this time, remember, I only had one of the 5ths, so I only have 3 of the 15ths. Okay, so 1/5 is the same as 3/15. Now, when I divide that by 3, I'm going to take one of each of my pieces. And this is the only piece I had, so when I take one of those, I end up with 1/15. So as an equation, I can write that as 3/15 divided by 3 is equal to 1/15. So I'm going to put that down here. And the 5/15 I got from the first whole, and the 5/15 I got from replicating that as a second whole, and then 1/15 from the 1/5 divided by 3 is equal to 11/15. So this would be 11/15 and work on paper. And now we have volume. What is the volume? Looking at our cube here, we can see that this is made up of 1, 2, 3, 4, 5, 6 cubes on this face here. 6 cubes for this, 6 cubes for this, and 6 cubes for this section. So 6 cubes stacked 4 times front to back would be 24 cubic units. Fill in the blanks to make the statement true. There are 24 cubic units in the box, therefore the volume of the box is 24 units cubed. Show your work using the formula. Well, for rectangular prisms, we know that the volume can be found by taking the length times width times height. Those are my 3 dimensions. The reason being my units are in cubic units each time we're finding volume. So the volume for this specific rectangular prism would be 3 by 4 by 2 units. 3 by 4 by 2. And 3 times 4 we know is 12, times 2 is 24 units cubed, or cubic units.